Question number 8a, we are asked to evaluate without using tables 5 log 2 plus log of 40 minus log of 12.8. And the B part, we are asked to find the equation of the curve which passes through the point negative 2, 5 and has a gradient of 6x squared plus 8x minus 3 at any point on the curve. And lastly, we are asked to differentiate the function 3x squared plus 4x minus 5 with respect to x. All right, let's get started. You should know that according to one of the laws of logarithm, this 5 can serve as a power of 2. So a part, we can write it as log of 2 raised to the power of 5 plus log of 40 minus log of 12.8. Let me remind you something. According to one of the laws of logarithm, if you have log of a plus log of b, this is the same thing as log of a times b if it is addition. And for subtraction, if I have log of a minus log of b, this is the same thing as log of a divided by b. So where we have addition, we multiply the arguments, and where we have subtraction, we divide. So this is the same thing as log of what? The whole of 2 to the power of 5 is 32. So we have 32 multiplied by 40, then divide by 12.8. 32 times 40 is equal to 1280 divided by 12.8. If you use a calculator, take 1280 divided by 12.8, that will give us 100 exactly. So this is log of 100. Now you should know that 100 is the same thing as 10 to the power of 2. So this is log of 10 to the power of 2. And this 2 can simply drop down to multiply, right? So this is the same thing as 2 log of 10. But what is log of 10? Log of 10 is equal to 1. So this is the same thing as 2 multiplied by 1, which is equal to 2. Therefore, the whole of this expression, when simplified, will give us 2. You should know that this is log to base 10. A log of any number having the same base as the number is forever equal to 1. So this is 2 times 1 equal to 2. Let us take the second question here under question 8. We're asked to find the equation of the curve which passes through negative 2, 5 and has the gradient 6x squared plus 8x minus 3 at any point on the curve. So what is this gradient? This gradient is nothing but dy over dx. So if dy over dx is equal to 6x squared plus 8x minus 3, to find y, we are going to integrate both sides with respect to x. Therefore, if you do the same thing to the left hand side, you have y, and we have to integrate 6x squared plus 8x minus 3 with respect to x. Let's do that. This power will increase by 1, it becomes 3. And we have 6 divided by 3, which is equal to 2. So we have 2x to the third power. This naturally has a power of 1. You increase it by 1, it becomes 2, and you have to divide by 2. 8 divided by 2 is 4x squared minus, if it is constant, just attach x, then plus the constant of integration. And hence this is the y, this is the equation. But we have to find the value of c. At what point? At a point where x is negative 2 and y equal to 5. So at negative 2, 5, we have 5 equals 2 multiplied by negative 2 to the third power plus 4, negative 2 to the second power minus 3, negative 2, then plus c. You should know that negative 2 to the third power is negative 8. Negative 8 times 2 is negative 16. Negative 2 to the second power is 4. 4 times 4 is 16. Negative 3 times negative 2 is positive 6. Then plus c, this is 5. This and this will cancel. And if you take 6 to the left hand side, it will become negative. 5 minus 6 is negative 1, and hence c is equal to negative 1. All you have to do is to bring it back in here, right? So y is finally equal to 2x cubed plus 4x squared minus 3x plus c, but c is negative 1, and hence this is the equation of that curve. Then lastly, we are asked to differentiate the function 3x squared plus 4x minus 5. So 8c, we are asked to differentiate this function dy over dx equal to, this 2 will drop down to multiply. 2 times 3 is 6. X, subtract 1, it becomes 1. You don't have to write it. Then this has a power of 1. It will drop down to multiply 4. Then x raised to the power of 1 minus 1 is 0. So x to the power of 0 is 1. So you don't have to write it. And derivative of constant is 0. So you see, this is the solution. Now let us move on to question number 9.